It says the Venn diagram shows a sample space and a probability of events A and B within the sample space. Given that the probability of A union B is 0.7, find the probability of A only. I don't like when you put Venn diagrams like this. I'm going to restructure it. It's a bad habit, but I like my Venn diagram with a box. This part is A only. They said the probability of A together is 0.6. I'm going to write this as 0.6 minus X. Then the intersection is X. And then B is 0.2 minus X. On the outside, all right, it's not written so well. I'm going to try and make some more space. (0.6) minus X and X for the intersection. And then over here is 0.2 minus X. This is what we're taught from primary school. Then on the outside is 0.3. That's our sample space. Now we know that probability of A union B is 0.7, but we know that the probability of A intersect B is equal to the probability of A plus the probability of B, probability of A plus the probability of B, minus the probability of A union B, and so the probability of A is 0.6 plus the probability of B is 0.2 minus the probability of A union B, which is 0.7. So that's 0.6 plus 0.2 is 0.8 minus 0.7 is 0.1. That's 0.1. And that's the probability of A intersect B. That's the probability of A intersect B. Probability of A intersect B is 0.1. Now that we get the probability of A intersect B, the probability of A only is going to be equal to 0.6 minus 0.1. The probability of A only is 0.5. So that means that this part is 0.5. This intersection is 0.1. This in here is 0.1. I didn't need the box, but I just feel nicer with the box. Now, it goes further to say, hence, determine if A and B are independent events. A and B are independent events if the probability of A intersect B is equal to the probability of A times the probability of B. Now, the probability of A intersect B, found that that is 0.1. And the probability of A times the probability of B, probability of A times the probability of B, that's going to be equal to the probability of A. Probability of A is 0.5. Well, A is actually 0.6 times the probability of B which is 0.2, and multiply them, and I get 0.12, and they are not the same. So I don't get the same thing, and so it's not independent. They're not the same. And since they're not the same, we can conclude that they're not independent. Hence, A and B are not independent events. Nice and easy. So they're not independent. Now, this question, question 5, says 2 balls are drawn at random without replacement from a bag containing 3 red balls, 2 blue balls, and 1 white ball. Represent the outcomes of the draws and their corresponding probabilities. So it starts out where you can draw 3 balls. You can either draw a red, you can draw a blue, or you can draw a white. Let's write that down. You can either draw a red, or you can draw blue, or you can draw white. Now, it's either you draw red, blue, or white. The probability of you drawing a red first is 2 red out of 6 balls, so it's 2 out of 6. Probability of you drawing a blue is 2 out of 6. Wait, it's 3 red, 3 out of 6. Probability of you drawing a blue is 2 out of 6. Probability of you drawing a white is 1 out of 6. Nice. And this is first draw. So I'm gonna write first draw up here. Should I use up the space more? No. Let's say they draw a red first. You can now draw a red and draw another red, or you can draw a red, then draw a blue, or you can draw a red, then draw a white. So this is the second draw. The second draw, you draw one already, so 5 available. And if you draw a red first, then there are 2 reds possible here. Down here would then be, if you draw a red, then the probability of getting a blue here out of 5 is 2. And then there'll be 1 out of 5 to getting a white. That's that. Now let's say you did draw blue now. I'm gonna have to extend this tree way out here just so they don't intermingle. I don't like how this looks. Yeah, I should have used the space better. One, 2, 3. So I'll put the whites them down like this. So let's say you draw a blue, then a red. If you draw a blue first, then you'd still have, if you draw a blue, you still have 3 red here, so it would be 3 out of 5. If you draw a blue first, then the chance of you drawing a blue on the second one is 1. I either draw a blue already, so the chance of you drawing a blue on the second would be 1 out of 5. And then the chance of you drawing a white would be 1 out of 5 as well. Now, going down. If you draw a white first, chance of you getting a red on the second is 3 out of 5. Chance of you getting a blue then would be 2 out of 5. Now, if you draw a white first, then there's no possibility of getting a white on the second draw. That's the tree diagram. Determine the probability that the second ball drawn is white. So the probability the probability that the second ball is white. That means that the first ball color don't matter. That means we need to find the probability of getting a red, then a white, plus the probability of getting maybe a blue, then a white, plus the probability of getting a white, then a white. Now the probability of getting a red, then a white means if we get a red on the first draw, that is 3 out of 6 times chances of getting a white on the second draw would be 1 out of 5, plus we get a blue first is 2 out of 6 times we get a white now is 1 out of 5, plus if we get a white first, probability of getting a white is 1 over 6 times we get a white second, then there would be no white. So we work that out and we get 3 over 6 times 1 over 5 plus 2 over 6 times 1 over 5, which is 1 over 6. That's the probability of getting a white on the second draw. That's that. Nice. Moving right along. It says, given that A and B are those two matrices, show that A times B is 20I. So we need to work out what's the matrix A times the matrix B. So the matrix A times the matrix B is going to be equal to matrix A, which is 1 minus 1, 1. Matrix B, which is 1 minus 2, 4. Matrix C, which is 1, 3, 9. That's matrix A times matrix B. Matrix B is 30 minus 12. 30 minus 12, 2. 5 minus 8, 3. Then you have minus 5, 4, and 1. So let's multiply them now. Multiplying them across, we're going to get row by column. It's going to be 1 times 30, 1 times 30, minus 1 times 5, minus 5 times 1. That's 20. But this is easy, man. All they're going to get is 20. We multiply them across to get 20, 0, 0, 0, 20, 0, 0, 0, 20. That's all I get. All right, and then you can just factor out 20. Let's say you're getting 20 times. You get this 3 by 3 matrix, 1, 0, 0, 0, 1, 0, 0, 0, 1. And this matrix is I. That works out to be 20I. I bet they're going to say, hence, find A inverse. They're going to say something like that. Hence, find A inverse or B inverse. But let's wait and see. So AB is 20I. Nice. Hence, find A inverse. I know it. Now, it says hence. Now, look at this. A times B is equal to 20. A times B is equal to 20I. Right? A times B is equal to 20I. And so, if I were to divide both sides by B, even though I can't necessarily do that, if I were to divide both sides by B, not divide by B, if I were to pre-multiply by A inverse, look what would happen. If I pre-multiply by A inverse, A inverse, I pre-multiply by B inverse. Why am I saying A inverse? Oh boy, my apologies. If I pre-multiply by B inverse, and I don't put it the right order, it's really B inverse times B. The B inverse times B become I, and so you get the B inverse times B becomes I, and so you get A is equal to 20 I times B inverse. And so what am I saying? If I were to flip it, I would then get 1 over A is equal to 1 over 20 times 1 over B inverse is just B. And so that implies that A inverse is 1 over 20B. A inverse is equal to 1 over 20 times B. Now, of course, you're going to have to put it in. So A inverse is 1 over 20 times B. Let's go back and look what was B. So A inverse is 1 over 20 times the 3 by 3 matrix B. And B is, let's go back around here. B is 30 minus 12, 2. 30 minus 12, 2. 30 minus 12, 2. 5 minus 8, 3. 5 minus 8, 3. And then minus 5, 4, 1. Minus 5, 4, then 1. That's A inverse. That is A inverse. So it says hence or otherwise solve the system. Now, since it says hence, I'm just going to go straight away and use hence. Solving this system, as I see, this is the matrix A, 1, minus 1, 1, 1 minus 2, 4, 1, 3, 9. That's the matrix A. So solving this system, I'm just going to go straight away and say hence XYZ is going to be equal to A inverse times 1, 5, 25. A inverse, which you know is 1 over 20 times B, and I have matrix B right here. It's 1 over 20 times 30 minus 12, 2 times 5 minus 8, 3 times minus 5, 4, 1. And this is, of course, multiplied by 1, 5, and 25. Nice and easy. Solved. So now you go ahead and you work that out. So you go ahead and you work this out, and so XYZ is equal to 1 over 20 times 1 over 20 times. You go ahead and work this out row by column. It's going to be 30 times 1 minus 12 times 5 plus 2 times 25. You work that out to get 20. Go here, you get 5 times 1 minus 8 times 5 plus 3 times 25, which is 40. Then you have minus 5 times 1 plus 4 times 5 plus 1 times 25, and you get 40. So what that is telling us is x is equal to 1, y is equal to. When you do the division, that will tell you that x equal 1. So hence, x equal 1, because you're going to get 20 divided by 20, y equal 40 divided by 20 is 2, and z also equal 2. Don't just leave it like that, check it. Check to see if 1 minus 2 plus 2 is 1, yes. 1 minus 2 times 2 plus 4. 1 minus 2 times 2 plus 4 times 2. That's fine. And so good. All of this is correct. Nice. So good. How many marks for this? Giving away 6 marks. We'll go to question 6. Question 6 says find a differential equation of this thing there. All right, so to find a differential equation of this, first thing we're going to do is divide through by 1 plus x squared. So we're going to get that dy by dx. So dy by dx plus 2x over 1 plus x squared times y. And that's equal to the cube root of x. That's equal to the cube root of x over 1 plus x squared. Now this is a first order linear differential equation. And so the first thing we have to do is find the integrating factor. To find the integrating factor is e raised to the integral of 2x over 1 plus x squared. 2x over 1 plus x squared dx. That's the integrating factor. Since this is the integrating factor, whenever the differential of the denominator is in the numerator, it's ln the denominator. So the integrating factor is e to the ln of 1 plus x squared. Now e to the ln cancel each other, and so you just get 1 plus x squared. That's the integrating factor, 1 plus x squared. So the general solution is y times integrating factor, y times the integrating factor is equal to the integral of the function of x that we have here, equal to your function of x times the integrating factor and so y times the integrating factor is going to be y times 1 plus x squared. So y times 1 plus x squared, and that is equal to the integral of f of x, which is this times the integrating factor. So it's equal to the integral of this, which is the square root, cube root of x over 1 plus x squared times 1 plus x squared dx. Now, as you can see, The 1 plus x squared here is going to cancel the 1 plus x squared here. And so we're just integrating x to the 1/3 power. To integrate x to the 1/3 power, what we're going to get is y times 1 plus x squared is equal to, you integrate x to the 1/3 power, you add 1 to the power, so it's x to the 4/3, divide by the power of 4/3, which is the same as putting 3/4 plus some constant k. Well, don't put the plus to constant yet, just write it as x/4, x to the 4/3, and then you can divide through by 1 plus x squared to get that y is going to be equal to, let me see the best way I can write it. I can say y is equal to 3 times x to the 4th power cube rooted, 3 times x to the 4th power cube rooted divided by 1 plus x squared plus some constant c times 1 plus x squared. That's going to be y. So right here, this is cube root. So let me try and fix this to make it a little clear. Maybe I write it in red. Maybe the red will be brighter. Nope, it is not. How can I make this brighter? 3 times the cube root x to the 4. That's a little better. Over 1 plus x squared. Hence, given that y equal to, when x is 0, calculate y of 1. So to calculate y of 1, you have to find the constant first. So when y equal to, x is 0, so 2 is equal to, looking back at it, x is 0, this becomes 0 in the numerator. This is now 0 in the, this is now 1 in the denominator. This becomes 0. And so 2 is equal to 0 plus c times 1. And so c equal 2. So therefore c equal 2. C is equal to 2. So since c is equal to 2, then we now know that y is equal to 3x to the 4th cube rooted over 1 plus x squared plus c, which is 2 times 1 plus x squared. So all you have to do now is go ahead and plug in x as 0. Plugging in x as 0 to get, plugging in x as 1, sorry, to get y of 1. Y of 1 is equal to, plugging in x as 1, 1 to the 4th power is 1. Cube root of 1 is, I think that's still 1, times 3. So that's 3 over 1 plus 1 squared is 2, plus 2 times 1 squared is 1, plus 1 is 2, 2 times 2 is 4. So that's y of 1, 3 over 2 plus 4. Which is 11 over 2. That's y of 1, 11 over 2. So y of 1 is 11 over 2. So now, since that's y of 1, let's go ahead and see now. Just want to check that this was correct. When x is 0, just want to make sure that we're getting the y as 2. So this would be 0. This part would be 0 over, this is 0. Yeah, this look right. 11 over 2. Right? It says now, use substitution u as y prime to show that the differential equation y double prime plus 4y equal this can be reduced to this. Well, if u is equal to y prime, then that means the u prime is equal to then u prime is equal to y prime prime. So that implies that, but I don't see what they want us to show. This is just straightforward. So that means y prime prime plus 4y prime, that part is now changed to be equal to u prime plus u, and it showed us that that was equal to 2 cos. I don't see what they wanted because that was so straightforward, which is equal to 2 cos 3x minus 4 sine 3x. That's it. No sugar to that question. Nice. Let's continue now. It says, hence or otherwise, find the general solution to this differential equation. This is the last question. Wow, that's fantastic. Let us find the general solution to this differential equation. So first we solve the auxiliary equation. So first you find auxiliary equation. So you solve auxiliary equation. Solving the auxiliary equation is just going to be, I like to use m. So it's going to be m squared plus 4m. M squared plus 4m is equal to 0. And so what you get is the roots of the auxiliary equation. You're going to get m times m plus 4 is equal to 0. And so solving this equation now, you're going to get m equals 0 or m is equal to minus 4. M equals 0 or m equal minus 4. So those are the roots of the auxiliary equation. So now you're able to write down the solution of the complementary function. So the solution of the complementary function, generally given as yc, roots of the complementary function, generally given as yc. So yc is going to be equal to, I'm going to write it as pe to the 0x plus qe to the negative 4x. All right, but this will just work out to be e to the 0 is 0, so the complementary function, yeah. So the complementary function is p plus, right, that p better, p plus q times e to the minus 4x nice and easy. That's the complementary function. So since you get the complementary function now, what do we do now? Well, what we do is we try to find the particular integral. So for the particular integral, we call it yp. Yp is going to be, based on this question, it's 2 cos 3x minus 4 sine 3x So yp is going to be a cos 3x. Yp is a cos 3x plus b sine 3x. That's going to be yp. So now what we need to do is find yp prime. So let's go ahead and find what is yp prime. Now yp prime is clearly going to be equal to, we're almost finished and we're feeling happy. So yp prime is equal to, when we differentiate cos, we get minus sine, so that becomes minus 3a times the sine of 3x. Plus, when we differentiate sine, of course, we get cos, so that's 3b times the cos of 3x. So that is, of course, yp prime. Now let's go ahead and finish it off by finding yp prime prime. So yp prime prime. So yp prime prime will just be differentiate sine, we get cos, so that's just minus 9a cos 3x. Then when we differentiate cos, we get minus sine, so that is just minus 9b sine 3x. Now, let's stick a pin right there. Stick a pin right here. But remember, this was what we had. Y double prime plus 4y prime is this. So let's go around and write that down. So remember, we had y double prime. We had y double prime minus or plus 4y prime. Wait, I'm not sure. Was it minus or was it plus? Let me check back. Plus 4y prime. So y double prime plus 4y prime was equal to, so where did this go? Okay. So y double prime plus 4y prime, we got that this is equal to 2 cos 3x, I think minus 4 sine 3x. Was it minus 4 sine 3x? Let's check back again. Minus 4 sine 3x, good. Now all we're gonna do is substitute y prime prime and y prime from around here. This is y prime, and this is y prime prime. We're gonna substitute this in that equation to solve for a and b. So it's minus 9a minus cos 3x minus 9b sine 3x. Let's go ahead and do that. So this becomes minus 9a sine 3x minus 9a cos 3x, sorry, then minus 9a sine 3x minus 4 times y prime, and y prime was just 3a sine 3x, or was it minus 3a sine 3x plus 3b cos 3x. Now, of course, this is equal to the 2 cos 3x minus the 4 sine 3x. Minus 9a cos 3x minus 9b sine 3x minus 9a cos 3x minus, this should be b. Just checking to make sure we don't make any typo. No typo at all. Around here is minus 3a sine plus 3b cos minus 3a sine plus 3b cos. So good now. Now we can go ahead and further solve it by grouping the cos them together. We're going to get minus 9a minus 4 times 3 is 12, so it's minus 12b cos 3x. So minus 9a minus 12b, put a bracket around that, cos 3x minus 9a. Why stop here? So it's, wait, come on, not yet finished. So it is minus 9a minus 12b cos 3x. Then I group the sign parts now to be plus. Grouping the sign parts, this look like positive 12a sine 3x minus 9b. So I can put it as 12a minus 9b close the bracket, sine 3x, and this is equal to 2 cos 3x minus 4 sine 3x. Now, since both are equal, we can equate the costs. So equating the costs, what we're going to get is equating costs, we're going to get minus 9a minus 12b is equal to 2. And the next equation we're getting is, that is 12a minus 9b. That's equal to negative 4. So now we're going to use these two equations to solve for a and b. All right. Now I'm in an elimination mode, so I'm going to multiply the first one by 9 in an elimination mode. So I'm going to multiply the first equation by 9. Multiply the first equation by 9, I get minus 81a minus 9 times 12, I don't know. That's minus 108 times b. Then 9 times 2 is 18. Then multiply the second equation also by 9 now. Multiplying this one by 9. I'm getting 9 times 12. I just said it, that's 108a. Then multiplying 12 times 8. Multiply the first one by 9. Multiply the first one by 9. That's good. And then I need to multiply the second one by 12. Oh. Let me check that again. 9 times 108. 9 times 12. Yeah, 108. Multiplying the second one by 12 now. 12 times 12 is 144. A minus 108 B equal to 12 times minus 4. I know that. Minus 48. So just if you want to be clear, if you just want to be clear, you can tell them right here, you were multiplying the equation by, just to be clear, you can tell them you multiply by, and just to be clear, you're telling them that you multiply the equation by, what was it? You multiplied by 9. And you can, just to be clear, you can tell them that the second one, you multiply by 12. Just so you have clarity in your paper. All right, so that's what we did. And now we're going to add these two equations. So adding these two equations, or it's not good to add, let's subtract them. Subtracting these two equations, rather, you subtract them, you're going to get minus 81 minus 144, that's minus 225. We get minus 225a. The b's cancel. Minus 108 minus 108. Then 18 minus 48 is 66. So minus 225a is equal to 66. Both of these look divisible by 3. And so I simplify it now to get a is 66 over minus 225. That's 22 over 75. That's minus 22 over 75. That's what we're getting for A. If that's what we're getting for A, we can find what is B now. Can sub in A anywhere here. So we're going to get 12 times A, 12 times A, minus 9 times B. That's equal to negative 4. Right? Can bring over. And so we get 9 times B is equal to 9 times B is equal to bring over the 4 over here. It's 4 plus whatever is all of this. 12 times minus 22 divided by 75, which is 4 plus minus 3.52. Then you divide through by 9, and so B is going to be equal to, 9B is going to be equal to 4 plus minus 3. That's 0.48. Then I divide through by 9 to get B is equal to 0.48 divided by 9. That's 4 over 75. Since I get A and B, now I can finally write the general solution. So I can say, so the general solution is given by the general solution. Remember, it's the complementary function plus the particular integral. So the complementary function we found was y is equal to p plus q times e to the minus 4x plus, I think it was a what plus a cos 3x plus b sine 3x. So it's going to be plus a cos 3x a, which is minus 22 over 75, so plus a minus 22 over 75 cos 3x plus b, which is plus 4 over 75 sine 3x. Minus 4 over 75 times the sine of 3x. Nice and easy, soft. That concludes this paper. Done and dusted. Nice. That concludes this paper. So good to go. Lovely. All right, so that takes care of 2017. Very easy paper. And I wish you all the best prepping for your exam.